stretches things. All right. Okay, good. Okay, you want to like be able to like record this as well?
Yeah.
Like you can't see this.
Okay.
Like.
I can. Don't worry.
Oh crap. Okay, yes, yeah. Just take a picture. Record that. Like, maybe if you like, it doesn't see right there, it might look silly. I don't know. Forget it. It's all like I'm not gonna get a good grade on this anyways. No, I won't. Yeah,
okay.
It doesn't matter how hard you work. Technology always screws everything up. All right.
Okay, go ahead.
Okay. So let's get started. You recording?
Yes.
All right. Okay, so second introduction. This is my capstone project. It's mandatory for all grade 12s. And it's going to be about anything you want, present however you want. Can you stop moving around? Okay. So this is about four-dimensional space. It's a difficult topic, so if you have any questions, just ask in the chat and I'll try to answer them. Alright, so first we have to look at what a dimension is in the first place. It's an axis of freedom, it's a way you can move around. Thank you. Alright, so perpendicularity means 90 degrees. 90 degrees is an angle. So we have this Apple Pencil here. It's one line, it's completely straight. If I add another axis to it, you can see they're perpendicular. If I add a third, we've got three. Notice each one is perpendicular to the two others. We try to add a fourth. We can't get a fourth because our space doesn't have, there's not enough space. We don't have all the directions needed. You see, we've got up, down, right, left, and forward, back, but we don't have that fourth axis to move around in. Now that axis exists, but it exists out of our realm. And to understand this, we've got to look at flatland. Flatland is an imaginary landscape that is completely flat. So like a tabletop, completely flat, and everything would be on the surface of this tabletop, a piece of paper. And there would be all sorts of things on it, but it would all be two-dimensional. So there'd be maybe people on it, but they'd be two-dimensional people, everything would be completely flat. And they would not know of any three-dimensional shapes. All they would know about would be flat land. They would see everything. They wouldn't see anything above, they wouldn't see anything below. They'd have an infinitely thin line of sight that they'd see from. And they wouldn't notice anything above or below, just like we don't notice anything to either side of our vision, and we'll maybe get to that later. So field of vision is what we're talking about here. So your field of vision, now you might say we have a three-dimensional field of vision, but it's binocular vision from two eyes. We have a lot of tools to help us perceive depth, but in essence our vision is two-dimensional. You can take a video on like a single camera and you can put it on a two-dimensional screen, you can watch it, and you can understand the 3D of it. So that means that the dimension of your field of vision is one dimension less than the dimension you're in. So we live in 3D, our field of vision is two-dimensional. Now, this concept holds true. It scales up and down perfectly. So if it's two-dimensional, if you imagine a two-dimensional universe, and you go out to record that, not from an above perspective, but from an in perspective, what you would see would be a one-dimensional field of vision, and you'd be able to see everything along a single 360 circle around you. And then you could use a camera that only is capable of recording one line of pixels, and you'd be able to see that, and you'd be able to understand it. So that's like two-dimensional universe, one-dimensional field of vision.